So in class we did a question about quick start batteries, and we wanted to do an inverse normal situation for that. Our quick start batteries, we said our random variable was the life in months of the battery, and the mean was 45 months and the variance was 8 squared, and they were normally distributed. The first question that we had was that if you had a guarantee period of 36 months, what percentage of batteries does Quick Start expect to replace? And we said they'll only replace batteries if the battery doesn't last up to 36 months. So less than 36 months. So we had the probability that X was less than 36. We standardized that in class and we got negative 1.13. We did the solution and ended up with 12.924% of batteries that they had to replace. Then the next question said, what should be the guarantee period if Quick Start doesn't want to replace more than 10% of its batteries? So it wasn't happy with this 12% idea with the 36 months of a guarantee period. So it wanted to know how long should it guarantee the battery for so that it's only replacing 10%. So we know that we want to only replace batteries that are lasting below a certain number, okay? And the proportion of those batteries is going to be 10%, which is 0.1. Now, if we draw our graph, we know that this is a symmetric normal graph. For us to have an area of 0.1, we have to be in that tail, okay? This is our Z tables. So for this area to be 10%, since our graph is centered at 0, this should be a negative Z score. But we can't find negative Z scores in our tables, so we're going to have to look for an equivalent positive Z score, okay? If we write this in terms of our x's, okay, we have a mean of 45. What we're looking for is some value A that leaves us with 10% below 10% of batteries that we are replacing. But remember that A is a positive number if we're talking about X. It's a number of months, okay? This is not a symmetric situation, all right? So if we need to find the positive Z score here, we're going to have to find some other number B, which isn't necessarily the same as A, because X is just positive numbers, it's just months. So first of all, on the side, we need to find what's the positive Z score, okay? Once we have a positive Z score, we change it to a negative so that we can find A. So let's do that first. So we want to find the probability that Z is below, Z is above, okay, in this area, Z is above some Z score. That probability is going to be 0.1. Because our sign is facing the wrong way, okay, we want this area, and our tables actually give us the other side. We have to say 1 minus the probability that Z is less than that Z score, okay. If we move things around, as we've been doing in class, we end up with that Z score being 0.9 on that side, okay? We can find a Z score for a probability of 0.9. From our tables, that Z score is 1.282. So we now know that the number that replaces this Z score here is 1.282. Which means the number that replaces this Z score on the other side is going to be a negative 1.282. Okay? Now that we know the Z score that replaces that, we can solve our problem. We would have to standardize this, and we know that the probability that Z is less than, once we've standardized this, it gives us some Z score that we know is a negative Z score. We want that to be 0.1, okay? We found that negative Z score already to be 1.282. So we know that the probability that Z is less than minus 1.282 is 0.1. And remember, this is a standardized value. How would we have standardized A to get minus 1.282? We would have had to say A minus the mean over sigma gives you that negative z-score that you got. Okay, so now we substitute what we know. We know that the mean is 45 from the question. We know that the standard deviation is 8. If you solve for A, you get that A is 34.744, which rounds off to 35 months. And that's our solution. So you had to do it in two parts. You had to do it on the side to find the negative z-score. Once you had that, you could plug in your negative z-score and then get your correct number of months.